Hello, everybody. My name is Rian Fenter. I am the Director of Process Support at Adaptive Computing. So what I want to do today is take you through our latest and greatest architecture, I want to call it, with our Moab grid environment, as well as where we interface that fully with our on-demand data center bursting into the cloud. So that would mean I have multiple data centers all over the world, all over the country, where I have Moab set up in each one of those data centers. And using the Moab's grid functionality, I have set up it's one of the architectures is a peer-to-peer communication, grid communication between the different Moab data centers, and where these fill up on-premise. And then as these on-premise resources start filling up, you've got users submitting more workload, and then you could use the cloud environment via on-demand data center where we burst those workloads into the cloud, into different data centers, different cloud providers. So let me go ahead and start sharing my screen here so that we can go through this. Right, so what I have over here, so let me just make sure my screen comes up. All right, so what I've got over here, so this screen you're seeing over here is my on-demand data center VM that's running in our data center in Florida. And I'll be logging into this guy, and I'll be logging in as an administrator. Now, keep in mind what you see over here is also available command line interface. I mean, understand that some people prefer command line, so that's absolutely available. Whatever you see over here is available on command line as well. Now, just to set the scene, I'm sitting in South Africa, by the way. I am VPN into our data center, and I'm managing all these environments from here. And I'm managing all these different data centers that are sitting all over the world. I'm talking about on-premise data centers where I've got Moab installations on each one of these data centers, as well as what you see over here is actually my on-demand data center cloud clusters that are set up within each one of those data centers. That gives the capability to burst, having that kind of hybrid environment. Or you can let Moab, being intelligent, schedule it aside. First I'll use on-premise, and then if I need more resources, it will burst into the cloud. Or I can tell it, you have to run where I want you to run. So that's absolutely available. Now, you'll notice that there are 5 clusters over here, and the top 2 are with OCI, 2 different clusters. Top one is Ashburn, second one is Frankfurt in Europe. Then my Amazon cluster is in Canada. Then I've got a Google cluster in United States, US East, and Azure, which is also US East. I believe that's Virginia. But anyway, you can see that all cloud providers, there's no limitation to which one you want to use, and you can use all of them at in one go if you want, and mix and match them. We understand some organizations have got the requirement for obvious reasons to have multiple cloud providers and different data centers, right? So I'm sitting in South Africa, and all of these different clusters are all over the world, right? So that's what makes it so actually amazing that you can manage all these workloads all over the world. Now, let me just drill down into one of these, just that you know where all of this is coming from. So these clusters are, as we call it, in a bursting state. I've kept them small for this purpose, for the demonstration purposes, but each one has got one node. For example, this one, OCI Ashburn, has got 8 cores, and it's in a down state. So that means the cluster head node is up 24/7, but the node is down waiting for workload to come in. So that adds additional cost saving. So we'll only start these nodes up as workload comes in, right? So this queue over here, you'll notice there's some workload that I've run over the last few days while setting up the environment. And mine in most of the cases only look for one core, one node. Depends on what's required, but then we'll start these up, and the node will start up and run, and then we've got something in the background called a idle purge, which means how long should we keep these up? Maybe the workload is done, you forget about those nodes in the cloud. Mine is set by default for 3 minutes in this case. So after 3 minutes, no more workload on demand data center. Well, actually, the instruction from Moab will be, listen, there's no more workload. This cluster is available, but nothing's happening on it. Let's take it out. And that's where you have a unit cost saving. Right. So you'll see I can jump between these different clusters. So now I'm in Ashburn. Now I'll jump to Europe. It's pretty amazing looking at that cluster. One node, I've got 8 cores. Then I'll jump from Frankfurt into Canada, right? Amazon Canada into that data center. Now into Google in United States, also 8 cores. And then I've got this one is in United States, that's in Zurich. Now, also keep in mind, you'll notice that I've given each one of these a different name. So this one says, even though different data centers different all over the world, this one says master. So that's on my master Moab data center, right? So this is where this one is connected to. So if my master data center Moab finds that there's no more hardware to run workload on, it will burst into this cluster. Then my data center 1 will burst into Frankfurt. My data center 2 will burst into Canada. Data center 3 into United States East via Google, and data center 4 into Zurich. So I've got 5 different data centers over here that I'm bursting into. All right, so let's log into my viewpoint side, which is the Moab viewpoint side. So I'm using something administrator called Grid Admin. That's the environment I've set up, and I've set up this user for this purpose. And I will be actually running some workload from my viewpoint environment. Now, what you'll see over here is, and somebody that maybe are familiar with Moab will know that Moab has got a user interface called viewpoint. So whatever you do traditionally command line from viewpoint or from Moab, you can do in viewpoint user interface. You can run all your workload from here. A lot of features and functions available. I won't be going through all of them, but over here is something important called templates. But before I look at that, if we look at my nodes, now those are the ones you saw within my on-demand data center side. Now you can see these are all my data centers. So each one of those Moabs running in those data centers has got its own node. So data center 1, 2, 3, and 4. The Moab node is my master data center. And then we'll notice that each one of those nodes for each one of my clusters in ODDC are also listed here. So my Moab environment is fully aware of all the different data centers being in a setup in a grid peer-to-peer architecture. So using a template, which I've set up over here, and I'll just briefly go into it and then we'll run it, and then we can just keep an eye and see how it runs. Moab Viewpoint has got a feature called application templates, very extensive. You can set up your applications, build them for yourself or for users that you can let them use them. And you can set it up in such a way that you prompt them to enter some information, or just give them information and say, well, listen, this is what's going to happen. So it's a lot of information they can make use of. Now, this one is the one I'm going to use called Grid Simulation Multi-Cloud Providers. So let me modify this one. So this is the one I set up that will have all of this workload that's being simulated, kicked off, being sent to all the different data centers, and then bursted into all the different cloud environments. Now, as you can see, this is a template that you can make use of. This is a whole kind of training for just this part, which is very extensive. It can be very extensively used. So the only part that I'm using over here is actually the script part that I'm making use of this template so that somebody can submit this from Viewpoint itself. Now you'll see. So let me make this a little bit bigger. You can see this better, and then we'll run it. All right, so this is my script. So I'm not going to go into too much detail, but I'll just show you that I'm going to kick off one job that will run for 30 seconds just to start the process. So it will use 4 cores on my master data center. You'll see the feature I'm using there is called master DC. So that's running on master data center. And Moab being a scheduler, I'm using dependencies because it's a scheduler, so I can set up jobs to depend on each other. So this bunch over here is dependent on that one to complete. When that one completes, all of these will kick off. Now, you'll notice that there's 5 of them. So on my master data center, it will use 32 cores. It will use full out all available cores on my master data center. And then I've got my data center 1, 2, 3, and 4. That's also going to run workload. And in those data centers, in this case, it's got 1 core available, and it's going to utilize that. I mean, so obviously that's just a simulation of the data center, what's available there. So the idea is to fill that up, and you'll notice that each one of these jobs will run. I've set it deliberately to run for an hour, right? So it's hogging up those resources in the data center for 1 hour. Nobody can use anything else. You have to wait. But in the meantime, I've got this section over here at the bottom where users are submitting more workload. So in this case, users are going to submit workload that will be bursted. That actually, in this case, they're using it on data center 1. So that's 1. And in that case, they submit it either that, well, they can submit it directly on that data center or from the master that will be migrated to that data center. So with a peer-to-peer grid architecture, you have the capability of running workloads directly from on a remote data center. So it doesn't have to be from the master. The master is aware of that, or you can do it as I'm doing it from the master that will be submitted all the way to all the different data centers. So this is the idea of, this is one user submitting workload for that cluster using everything available. If I scroll over to the right, you'll see this one is going to use 1 node, 8 cores. Then my data center 2 Amazon cluster with AWS is going to use 2 cores, 1 node. And then data center 3 is Google, and it's going to use 1 node, 8 cores. And then I've got my Azure cluster, where it's going to use 1 node, 8 cores. And then our final one, which is on the, I call it on the master. So I've got on the master data center as well. It's going to use, and that's for, again, for OCI, an Ashburn OCI, where it will use 8 cores in 1 node. Right. So that's just to quickly review what actually is going to happen, right? And obviously that takes a bit of time to happen, but I want to explain that, so that's good. Right, so the simple as clicking on workload, and you want to run this as a user, you set this up for somebody so that they can go ahead and keep this off so that it runs. So I'm going to go ahead and create this. Now, as you saw within the template, there's a lot of fields that I can enable for users to type in some information. So I'm going to use the grid simulation multi-cloud providers. Use that one. In this case, it's not going to ask me to add in any information. I could have set it up that will give me a job name, say how many cores, how many nodes. There's multiple things that you actually can make available. So I'm going to just go ahead and create. So this will kick off this template. Will first of all run itself a job that is kicking it off, and then after that, all my workloads will actually be, kind of kicked off, which is the 30 seconds. So now see, now it started to list all of these workloads of mine. And remember, my first job was a job that ran for 30 seconds using 4 cores, and all of these are actually dependent on this guy to complete. So now we can see that all my other workloads are waiting. So you'll notice the ones that say 3600 are the ones that run for an hour. And it says grid admin, which is this guy is going to run on all the remote data centers, and then all the different user jobs that also came in. That has got jobs that's going to run for 5 minutes, and they also need to run. But now, as soon as these have been migrated, as we call it, to all the different data centers. Now you'll see things starting to change. I can briefly jump into my command line interface as well. So I've got a session over here running. So this is my master data center I'm looking at. And I will see there's Moab DC 1, 2, 3, and 4. So I can click on each one of these and see as workloads start arriving. So they say Moab Data Center 3 is already started receiving one of the on-premise jobs. Now you can see this one that says 4,3600 seconds is going to run for 1 hour using one core. That's what, in this case, is available on-premise. Then I've got a user job. You'll see at the bottom is in a block state, but that's correct because now it's waiting for a cloud node. So you'll see there's something called power. And that's actually sent an instruction to my on-demand data center side to say, listen, there's resources required here. Let's start them up in the cloud. We need to run this job. And this is going to be the same for each one of these different data centers. You'll see that was the data center 3, 4 is the same situation. We can see it 2, same situation. And 1 is still waiting for its own job to come through. And this is the master where you can see all these processing happening. And you'll notice that it talks about migrating. So it's in the process of migrating workload. So that's the DC1 that we were just looking at. It was busy migrating that to Moab DC1. Now you'll see, just now it was nothing in here. Now it's migrated all that workload over to there. And we're busy running. And these guys over here at the top are actually my master node. So where it says on-prem. So that is using 32 cores. And the one that's at the top there, it says OCI Master Ashburn. That's my power job. And that's what it needs to start up the cloud resources. So the whole process are fully automated. Moab is taking care of it, migrating all this workload to all these different data centers all over, let's say, the world for that matter. Now, let me go back and you'll see on the viewpoint side, we can see as our workload runs, we can look at our nodes, and you can see as these nodes are being allocated against these workloads, we will see whether they're busy or available or partially available as workloads happen. Now, let's go back to my on-demand data center side. Right, so let's start here at the top. So we filled up on-premise, right? And now we have to start deploying some of these nodes. Now you'll notice, remember we saw the power jobs. That's instructions from Moab to on-demand data center. Listen, here's a job waiting. It requires a certain amount of cores. It's available in this node. Start it up. It takes about 4 or 5 minutes for these to start up. And this is on my master data center, OCI Ashburn. Let's have a look at my Frankfurt one. And I'll just go through these briefly. Same thing. Also waiting or deploying the node. Of course, it's received the instruction. In my Canada data center, same things, busy deploying. And we will see, and my Google one is also busy deploying. So I'm looking at my Google cluster. And then we can have a look at my Azure cluster. So this one is still waiting for its instruction. So as soon as it gets instruction, it depends on how the migration happened. Oh, this one is already actually deployed. And now what we'll see soon is we will get the job actually in here in the queue over here. And then this will change into a busy state, meaning my job. Now, first we start up the node, all right? And then as soon as that part of the process is completed, Moab will actually pass over the actual job that needs to run on this node. So we can have a look at, and that is actually data center 4. We can go back over here and see what's happening over here. So now you'll see that that job is now in the queue over here that it needs to pass it over. This is my on-prem resources being utilized. And then as part of the, as we call it, we call it a burst or a scheduling cycle. So as soon as this is ready, Mo will do its cycle, then it will pass it over into this queue, and that will happen on all of these. All right, so now we can see that user job is already running. That's on my Google cluster. there is my Power Job is still running on this guy, and my Power Job. So we can see on the Google one, it's already running its job. So we can start having a look at that. So this one will arrive shortly. So let's have a look at my Google cluster. We should see that now. You'll notice that my job is actually busy running, right? You'll see that the job has been asking for 8 cores, 1 node. So we started that up and is using all available cores, right? So now that means even though those jobs that utilized all my on-prem resources within the data centers via the whole Moab grid environment, and as you utilizing it for an hour, we can still take care of all these other workloads that also come in using a hybrid environment with it's fully automated, right? Moab is aware of these cloud resources. We configure and do the installation accordingly, and we deploy these clusters and have them ready for any workloads that come in, right? And then we can actually take care of these workloads. Now, these could be workloads that are just generating some output, using some input data. We've got customers where we actually set up, we set up like file storage for them within the cloud provider, or they make use of their own stored input data on premise. We've got within the Moab environment, we've got something called data staging. So we stage that data from on-prem into the cloud, first copying the data over and then only running the workloads multiple ways. So it really doesn't matter where the data is coming from and going to. We set it up according to that. So that's why we call it data anywhere for that matter. And that will happen with each one of these clusters. Now you can see that on my master, I'm only using 1 core. Of course, my job is only require one core, and that's fine. So we start up and we're using 1. So if there's another job coming in, there's another 7 cores available. Let's see, on my Frankfurt one, most probably this is also busy. So my job has come through, and as we looked at, I think we did look at Canada, but we can have a look at that one as well. And we looked at this one, and hopefully this one has already gone through as well. This one is ready to run its workload. Now it's busy destroying it. Remember, if there's after a certain amount of time, no job that's allocated against it, we start up the node, or the job has actually been run. So this one is actually after. Remember, I mentioned in mine is there's an idle purge of 3 minutes. Customers set them up to hours, days. This really depends on how long they want to keep them up. And that's the same with all of these different clusters, that depending on when this is completed, this job is running for plus minus 5 minutes. When it's done, wait another 3 minutes. Then we just start destroying each one of these nodes. And I want to end off at that, so again, from the viewpoint side, you can monitor all your workloads as it keeps on running. You can check if there's maybe, sometimes jobs fails because of some funny reason. You can check those outputs, and the whole environment is set up where the user that submits the jobs from Moab, and I think that's something people are familiar with, that writes the output data back to the user that submitted it, whether it's, sitting on premise or on another environment within one of the data centers. It will be actually written to that user. All right, so I want to finish off by that and saying that, so now we've gone through the process of using a full grid environment, peer-to-peer configuration. In this case, there's different configurations that can be used where, for example, you set up your remote data centers as slave environments, as we call it, which is not maybe a correct term, but it is. It means that that the data center, the remote data center, only can receive. It cannot, you cannot submit workload directly within that data center. So there's different types of architectures we can make use of. And as I mentioned, and you saw, that as those on-prem resources get filled up, we burst further into the cloud. In this case, I was using 5 data centers and bursted into 5 different cloud providers, 5 different clusters, different shapes and sizes. All right, thank you very much for your time, and hope if there's any questions, obviously you can contact us at Adaptive, and we can do a much more in detailed update on this. And as while I was talking, you would notice that one of the jobs completed in this node will be destroyed shortly. Anyway, thank you very much, everybody, and have a great day further. Thanks. Bye.